Twinkle, twinkle, little star, but I really wonder how. Well, the lullaby itself has got a major part of the answer, but before we get into that, let me ask you this. If there is a source of light, it's emitting light in all directions for sure, and the light goes into you, into your eyes, after suffering, say, refraction. So let me just refract the ray. One ray was coming and it refracted and it went into your eye. That's your not so beautiful eye, and say an apparatus through which the refraction happened. Now, why would this source seem to twinkle? What is twinkling? Why would you see it twinkling? What makes any source twinkle? If you at all see a source to twinkle, what would you do to this source such that it twinkles? So I would say it twinkles because, well, it will seem to twinkle if the light which is coming to your eye sometimes comes, sometimes it doesn't come, it fluctuates. So the light coming to your eye, if it fluctuates, it will seem as if the light source was twinkling. I would like to draw your attention to, say, the two stars in the corner. So can you see, it seems as if the two stars are twinkling. Those are in fact points, and it seems to be twinkling. And as I said, I am reasoning out that they are twinkling because the light which is coming from the star to our eyes are not constant, they are fluctuating. Now, why on earth would that happen? Because a star is a source of light which is, by all means, we can consider it to be constant. It is going to be lit up for billions and billions of years, right? So light coming from a star is very much consistent, and this is not fluctuating at all. The light which is coming out from the star is same all the time. It's not glowing brighter and dimmer. It is just glowing with the same intensity all the time for years and years and years. So why would I say that the light coming from the star is twinkling? I guess, guys, you know the answer already, but we have to be careful with words. What wrongly we write is, it is due to atmospheric refraction. No, due to atmospheric refraction, we knew what happened. Due to atmospheric refraction, say this star over here, this star, that seemed to have gone up, right? That star seemed to have, it appears to be there, higher up. So it doesn't appear to be down there. It doesn't appear to be here. We don't see it over here. We see it over there. It is high up over here. Now in its apparent position, it is going to twinkle. The light which is coming to our eye, say we are here, and that's a straight line, no bending and all. Why? Because that's the apparent position of the star. The bending of the light happened to the ray which is coming from the actual position of the star. That went and that bent and all. So we have done that. I'm not going to repeat that part. But at the apparent position, it is going to twinkle. Why would it twinkle at the apparent position? The star is going to give constant light even from the apparent position. That's the position of the image. It is going to give the constant light. It is going to twinkle because the layers of the earth is not going to have, the atmospheric layers of the earth is not going to have consistent density or optical density all the time. These layers through which the ray is passing and reaching the eye is having variable densities. It is having fluctuation in the densities as hot winds, cold winds are blowing. So the optical density keeps changing, say very minutely, because after all, the density of vacuum and air itself is having a very minute difference in refractive index. But that minuscule change, that minute change is going to do something. What is it going to do? It is going to bend the ray slightly more or slightly less. So if it is going to bend the ray slightly more or slightly less, then some of the rays might be missing the eye. So let me just make an enlarged image over here. That's your eye. And rays are coming from a certain star into your eye. So it has bent and come. So bending part is not so important. So just for the ease of making the diagram, I'm just going to make them all straight now. More the number of rays I show, more it means is the intensity. Okay, it's just a representation. Number of rays is a representation of how intensely the light is coming into your eye. These stars are really far away. It has got immense power. Lot of light is coming out, but since they are light years away from you, the nearest one next to apart from the sun would be some 4 light years away from you. So Earth is just 8 light minutes away, right? So it takes 4 years for the light to come from Proxima Centauri, right? So they're really far. So the intensity which comes to your eye is really less. Those lights which are coming into your eye is coming after suffering a refraction, right? We know, and the refraction has been suffered, and they have actually come somewhat like this. Just wanted to avoid making this, but anyways. So it was actually coming from somewhere over here, right? Say this is a atmosphere. Now, due to variation in the densities, the optical densities of the various layers due to winds blowing, what is going to happen is sometimes the bending will be more, sometimes the bending will be less. So it may happen that due to some extra bending, some excessive more than the bending I've shown, what is going to happen is not all these lights are going to go into the eye. Small change in bending, very small change in bending may eventually result in maybe only these rays going in and one ray not going into the eye, a few more not going into the eye. It may happen for a split second that none of the rays goes into the eye. The star is just switched off for that split second or even more. So since there is variation in the atmospheric refraction, the amount of ray coming from the star and entering the eye will keep fluctuating. Hence, the intensity perceived by the eye will keep fluctuating, sometimes more, sometimes less, sometimes say 5 rays, sometimes only 1 ray, sometimes none of the rays. That means the star is going to twinkle for us. It would seem to twinkle. Sometimes this ray will seem to be of higher intensity, sometimes of lower intensity. That creates a twinkling over here. That creates a twinkling of the star. I hope you have understood why it twinkles. But then why sun doesn't twinkle, moon doesn't twinkle, or to make the question more interesting, planets don't twinkle. So as I said, the lullaby itself is having a major part of the answer. One of the most important part of the answer is the star is little. Little star, you remember that. Meaning to say, the stars are so far that they act as point bodies, having very little extension, meaning to say very small bodies, tiny bodies, having very low intensity. So if the intensity will be that low, what is going to happen? A little fluctuation in the intensity. Is going to actually make a big difference. So the point over here is, since the intensity of the light received by star is very weak, the intensity of the stars are very weak, a fluctuation in the amount of received light is going to give us a perception as if the star is twinkling, as if it is not giving light and then giving light and then not giving light. Had it been an extended body and not a point body, that the fluctuation wouldn't have created a feeling of twinkling. I'll just show you by a small animation, but let me just write down the first major point. White star twinkles, why it seemed to twinkle. And the reason is because of fluctuation in the amount of atmospheric refraction. Fluctuation in the atmospheric refraction. So just to reiterate, the twinkling of the star is due to fluctuation in the atmospheric refraction. The word fluctuation is the key and not the word atmospheric or the phrase atmospheric refraction. Due to atmospheric refraction, the star seems to appear at a higher elevated position. It seems to appear at an elevated position or a higher position. That is due to atmospheric refraction. But at that elevated position, the star twinkles. The star twinkles because of fluctuation in the atmospheric refraction. And the fluctuations would not have actually caused any twinkling had the star not been a very dimly lit, seemingly weak source of light, seemingly a point body. Had the star not been a point body, the fluctuations would not have created a feeling of twinkling. They are twinkling due to fluctuation because they are point bodies. If they were larger bodies, extended bodies for the human eye, then they would have not, even with the fluctuations, the stars would have not twinkled. I hope you are getting the point over here. The point is, stars need to be a point body for the fluctuations to make it twinkle. Now, when I say stars are dimly lit or they are very, very small, I hope you know that what I mean over here is they seem to be dimly lit, they seem to be very, very small because they are so far away. Most of the stars are much larger than sun, much brighter than sun. So the great distance between a star and us qualifies them as point bodies, and much smaller bodies compared to them, like planets or our moon or even a man-made satellite, may seem larger because they are much nearer to us, right? A man-made satellite, if we are able to see, they will twinkle. It would be a good read for you guys, a good experiment for you guys to go out and check out a man-made satellite and see whether it is twinkling for you or not. The International Space Station, you can actually view early morning, so you can Google it, how to view, when to view and all. But twinkling is very much subjective. If the fluctuations are not happening, then maybe something which twinkles will not be twinkling that time, right? So the ones who observe the stars would be knowing what I mean. Now, why would a planet not twinkle? Sun doesn't twinkle, moon doesn't twinkle, I know. They are large extended bodies. Even a planet, like I would say this one over here may qualify to be a planet, looks large. A planet wouldn't twinkle because, being large body, the intensity of light coming from the planet is much higher. So again, say this is your eye, and the amount of rays which is coming from the planet is much higher. And with these many rays, if you are not reaching, and most of them are reaching your eye all the time. Maybe one is gone from here, other time one ray is gone from here, but the ray from here is reaching. So most of the rays are reaching your eye. Doesn't give you a twinkling effect of the planet. It seems that pretty much the whole body is there. I'll just show you in a small animation. So here I've kept a planet which is a extended body, and I've kept a star beside it which is a point body. What it seems to us, planet being much nearer, it will look that much, it is that much bigger for us than the star, which is way far away. So the planet can be thought of many point bodies like the star. So that is how I have shown it over here. And as the star is twinkling, I am making all those point bodies which is making up the planet also twinkle in the same way. So since it is enlarged, you may not get an effect of twinkling of the star. But see, when I zoom it out to the size that the star is a point body and planet is almost a point body, then you see what happens. Can you see that the star is having enough twinkle, right? It is we can really observe it to be twinkling, whereas the planet seems to be more or less giving the same amount of light and hence not twinkling. It is there like a stud but not twinkling. So I hope you got the answer. So what should you write? What should you write? You should write why planets don't twinkle. That's the question. And your answer should contain that planets being much nearer seem like extended body or bodies, planets extended bodies for us, for the human. And since they are extended bodies, the intensity of light coming from them is enough. And even with fluctuation in the atmospheric refraction, it doesn't give us the twinkling effect. The extended bodies part is required. Enough intensity is, you may write, the planets have enough intensity which is negating any fluctuation in any effect of fluctuation in the atmospheric refraction. So I hope you can answer why planets do not twinkle, extended bodies. Why star twinkles? Because they are point bodies and due to fluctuation in the atmospheric refraction. So that concludes this part. I hope you'll get it right in the exams. Thank you. But before signing off, I really wanted to show you a lovely pic. This is the actual photo of the planets in the sky. You see, that's your south here, that's your east over there. Moon not very much visible, but the curvature is over here and the curvature is somewhat this way. Maybe it's not visible to you. So that big would be a moon, just for your reference. So that's Venus, that's Mars, that's Jupiter, that's Saturn. So wouldn't twinkle, I would say, particularly Venus, the evening star. So from the picture, it would be very clear that Venus is not going to twinkle for sure. Jupiter also doesn't twinkle for sure. And Mars, it depends really. So it may not seem to twinkle at times. At times it may twinkle. Saturn may twinkle. So if they ask you why planets don't twinkle, it's not like all of the planets don't twinkle. The ones which are really extended bodies for us, which are big for us, they will not twinkle. This one qualifies. Mars may qualify. Saturn may qualify or may not, but Uranus, which is like barely visible, will not qualify for sure. Uranus is a massive planet, but it is way far off and it does twinkle for us. So I hope you understand when they ask why planets don't twinkle, they generally mean to say the near planet, the morning star, evening star, they don't twinkle, right? So that's it, guys. Thanks a lot.